All right, let's move on to radicals, solving radical equations. Now, in the steps here, they talk about what you do if you solve a radical equation that has two radicals, but none of these do, so we're not going to worry about that. I'm not seeing any that do. So, main thing to remember when you're solving radical equations, number one, you always want to isolate the radical. Isolate the radical before squaring each side. Now I say that seeing that all of these are square roots, so we will square both sides. If you had a cube root, you'd cube both sides. But the other thing is you want to check your answers. And so, especially with square roots or any even root, and normally we end up working with square roots, so that's an important part. It's always a good idea to check answers when you're solving equations, but when you're solving radical equations, you really need to check your answers. Okay, so this one's all set to go. All we got to do is square both sides. Notice, see, the thing is sometimes students will want to add 16 to both sides here, but we can't just pretend that radical's not there, and we don't know that we can do that. So if in doubt, it's never a good idea to do something if you're not sure. If I got rid of the radical, then I know I could add 16 to both sides. So the opposite of taking a square root is squaring. And so we're going to square the left side. Well, whatever we do to one side, we got to do to the other. So we're going to square the right side. Of course, if you take the square root of something and then you do the opposite and square that, you're going to end up with what you started with, 5x minus 16. Over here you get 49. We'll add 16 to both sides. You get 5x is 65. And we'll divide both sides by 5. And we get x is 13. Now I probably shouldn't have circled or put a box around this answer yet until we make sure it's right. I just happen to know that it does work. Whoops, 5 times 13 minus 16 equals 7. So this is 65 minus 16, which is 49. The square root of 49 equals 7. That is correct. So it does check. So again, it's always a good idea to check that. Let's move on to number 10. Now this time you see the 7 is on the same side as the radical. We just talked about how we need to isolate the radical basically by itself on one side before we square both sides. So let's get rid of that 7. Again, there's no way we could add this 7 with the 2 because the 2 is under the radical. But we can subtract 7 on both sides. We get 5 is equal to the square root of 3x plus 2. And now it's just like what we just did. We'll square both sides. We get 25 is equal to 3x plus 2. We'll subtract 2 on both sides. We get 23 is equal to 3x. And I'm just going to switch sides. Put my x on the left, divide by 3. We get x is 23 thirds. So again, you should check this. Basically, if you multiply 3 times 23 thirds, you'll end up with 23 plus 2 is 25. The square root of 25, which is 5, plus 7 is 12. The check does work. You can do it in your head, or you can do like I did over here, just to make sure that it's right, either way. Okay, so number 11 and 12 are going to be a little bit more work for us. We're going to do the same thing here. We're going to get the radical by itself. You get the square root of x minus 1 is equal to x minus 3. And we're going to square both sides. Now this is where you've got to be careful. By the way, x minus 3, these are not like terms. Sometimes I'll see students end up with like a negative 3x here or something like that. The problem is they're not like terms. You cannot add them together. So we'd want to put the x term first and then the constant. So let's square both sides since we got the radical by itself. However, remember what I just said, square each side. We've got to square the whole side. We need parentheses here. And now if you know your multiplication of binomials, you know that you can't just square the x and the minus 3. On the left, we're just going to get x minus 1. That's the easy part. On the right, we're going to have to multiply x minus 3 times itself. So you can FOIL that out. I'm going to assume that you can do that. And you would get x squared minus 6x plus 9. Now keep in mind, at this point, now we need to think, notice this is quadratic. And so think about what we were doing with quadratic equations. Our go-to method is basically the factoring method, which means, and even if in the other technique we used was quadratic formula, with both of those, we need 0 on one side and everything else on the other, and we want to write it in descending order. So let's get rid of the x here and let's add 1. So subtract x and add 1, so we got to subtract x over here and add 1. Notice I put those under their like terms. You get 0 equals x squared minus 7x plus 10. So again, because this is a 1x squared, we can factor this one pretty easily. It's kind of like what we did with the AC method, but once we find our numbers, we just plug them in. So we need two numbers that multiply to 10 and add to negative 7. You should check that out and you'll see that it's negative 2 and negative 5. When you multiply, you get 10, and when you add, you get negative 7. So we're going to end up getting an answer of x is 2 and 5. However, remember, we need to check our answers. And 5 checks, you can put a 5 in here, and you're going to have 5 minus 1 is 4. Square root of 4 is 2. And 2 plus 3 is 5, which is what we said x is. However, what if we put in 2? So let's check it here. Square root of 2 minus 1 plus 3 equals 2. Well, that's 1. 2 minus 1. Square root of 1 is 1. 1 plus 3 is 2. That's not true. And so that doesn't check. Only the 5 works, and that's our only solution. All right, so I would encourage you to try 12. It's the same basic steps. Notice here, though, you're going to have to add 4 to both sides. So give that a try, and I'm going to put up the answers. So you may want to stop the video and do it. All right, let's see how you did. There's your work. All right, so I'm going to stop. Let's see, actually, I think we'll just keep going. We got one more page. I think we can handle it. All right, so let me. All right, so on number 13, we have x to the 2/3 power is equal to 4. So we did something like this a little bit earlier. We can take this to a power and get just x to the 1 power or just x. So what do we need to do that? Well, if we multiply by the reciprocal, which is the 3/2 power, that would give us 1. These are reciprocals. When you multiply, you get 1, so it's x to the 1st power. And so we have to do 4 to the 3/2 power. Now, you could certainly plug this into your calculator, but I want to remind you what this is. The denominator tells you the root, and the 3 tells you the exponent. And we would want to write this as the square root of 4. That's what the 2 is asking us to do. Take the square root and then raise this to the 3rd power. Now I could put the 3 in here, but the easiest way to deal with a problem like this is to put the 3 out here. So you really have 2 options. The other option would have been to write it this way. But this is the easiest way. Of course, the square root of 4 is 2, and 2 cubed is 8. This is the square root of 64, which would also give you 8. But in general, we put that power outside. All right, so that's number 13, and you can verify or check that 8 to the 2/3 power is equal to 4. Let's go ahead and move on to number 14. In fact, I would encourage you to try number 14. Really, you could do the last 3 problems. Just notice here, this will be a lot like the one we just did. And then down here, you're going to have to move the 7 first and the 5 first, and then it's very similar. So go ahead and try those and then watch the video. So here, we're going to take x plus 1 to the 1/5 power to the 5th power. Of course, we'll do the same thing to the other side. Now be careful, you want to put the -3 in parentheses, although if it's an odd power, it won't make a difference. If it were an even power, then it would. So when you multiply the exponents here, you have a power to a power. We use basically this property here. If you had a power to a power, you multiply the exponents. It's called the power rule. So we're doing the same thing here. We end up with x plus 1 to the 1st power, or just x plus 1, and -243 on the other side. We'll subtract 1 on both sides, and we get -244. And again, you can check that. So -243 to the 1/5 power, you can verify that that does equal -3, so that does check. All right, I'll do one more with you, and then I'll just show you the answer to number 16. So here I'm going to subtract the 7. And then we're going to take the 2/3 power of both sides. And let's see, we're going to get x plus 5 on the left. Again, we multiply power to a power, we multiply the exponents, reciprocals multiply to 1, and you're left with x plus 5. Over here, this is the cube root, the denominator tells us the root, of 8 squared, or again, we can put the 2 out here, which is preferable normally. Get x plus 5 equals, well, the cube root of 8, well, what number to the 3rd power gives you 8? That would be 2, and we're squaring it. So we get x plus 5 is 4, which means x is -1. And you can verify that if you plug in -1 here, 4 to the 3/2 power plus 7 is 15. You can check that on your own. Again, I would encourage you to do 16 if you haven't already. It's very similar to what we just did. And there is your solution. And that's it for this video. And in fact, that's it for section 1.6.